And this is question 6 on page 148. I'm going to do 6 and 7 and then we'll look at the assess for sure. Now this is question 6, as I said. It says Jake says that B is the image of A after a translation by vector 4 minus 2. Let's just check it, shall we? B is the image of A. In other words, A is doing the moving. 4 minus 2. 1, 2, 3, 4 minus 2. No, nowhere near. Perhaps if we try 2 squares for each unit. 1, 2, 3, 4 minus 1 minus 2. Nowhere near. So it is not a translation. First we need to say Jake is wrong straight away because A does not glitchy does not translate onto triangle B. Alright, that's enough said, so Jake is wrong. Now what about Monique? Monique says Jake is wrong. Fine, that's not good enough. As A and B are not congruent. Well, are they or aren't they? Let's just take a good look. Well, let's have a look at A. A is 3 units across. In other words, it's got a base of 3 units, but so has B. What about the height? Right, A's height, 1, 2, 3, 4, 5, 6. B's height, start from here, 1, 2, 3, 4, 5, 6, 7. No. So, right. The triangles are not congruent. We have to give an example, right? Just to prove it, rather than just saying, "Oh, Monique is right; they're not congruent." Because, let's give one reason. This pen's really getting stuck. Because I can spell because honestly. A has a height of 1, 2, 3, 4, 6 units. But B has a height, I'm getting a bit better, of 1, 2, 3, 4, 5, 6, 7 units. And for that reason they're not congruent alone. Alright, which means that the hypotenuse, the longest side, would be completely different as well. Also, therefore, this angle does not correspond to that one, and this angle cannot correspond to that one, although these are both 90-degree angles here and here. Alright, we've said enough. So Jake is wrong because A does not translate onto B, so it's not a translation. Monique is right, one reason, because the height of triangle A is less than the height of triangle B, even though they share a common base of 3 units. Right, that's enough just to nail that one. And here's the next question, a little bit more tricky. It says which of these shapes are congruent to P. So P is what we're aiming for. Right then, remember, identical lengths, identical corresponding angles. Straight away, Q is one, look at that. We've got 1, 2, 3, 4 units along the base and 2 units tall. That's 1, 2, 3, 4 and 2 tall. So I'm going to put a ring around Q. That's congruent to P. R is exactly the same. I know it's sticking up in the air, but it's basically 1, 2, 3, 4 the base and 1, 2 the height. So Q, R and P are congruent. Now I know this is a little bit stretched wrongly, though I've put it onto the screen here, but S is also congruent. Look at it. 1, 2, 3, 4 units across and 2 units tall, and all these 3 match. U is not congruent, although it's 2 units tall here. It has a much sharper angle joining that vertex to that vertex, and besides that produces a base of only 3 units. This one looks congruent. This has a base of 2 and a height of 1, 2, 3, 4. It's not the same as having a base of 4 and a height of 2, because the slants are all wrong. So T is not congruent to P. So who are the friends of P then? Q, R and S. These are congruent to P. So we just write it down. So we've got Q, R and S. Alright, these are three congruent triangles. Sorry, congruent, and I suppose they're parallelograms, aren't they? And that's it. Now, describe each single transformation that maps P onto each of its congruent images. Alright, let's go from P to Q. That's really, really easy, because I can see that straight away. Let me do it. Okay, so that's that. I think I can draw a line straight across there, and if I reflect P in this line here, I'll end up on Q, and that is the line y equals 1. So essentially, save me writing it down because this pen's not behaving. Reflect P in the line y equals 1 to map onto Q. Now, P onto S is very, very easy. I can see I've got a vector there taking me from P to S, so I need to translate it. So if I take this point as the leading point, I'm going to the left 1, 2, 3, 4, 5, 6, 7, 8. So it's -8 going in the left direction, and then I'm going to go 1, 2 down, -2. So here are the 3 marks. It's a translation, and it's using vector -8, -2, and that's enough for 3 marks. Here I should use the word rotation, really. Sorry, reflection. So it's be a reflection. Here's me saying I'm not going to write it, but here I'm not helping myself. So I'm going to reflect P in the line y equals 1, and I'll end up on Q. And finally, this one's clearly a 90-degree rotation going that away. So let's just write this down. 90-degree anti-clockwise, and it's a rotation. Now, centre of rotation, again, no tracing paper, you have to do this mathematically. I can see I've got 3 units separating that vertex with that vertex, so I reckon the centre of rotation will be somewhere in this position here. And according to the answer book, and I'll give you the answer straight away, it's -1/2, 3. So they're saying the centre of rotation is right here. Now you need to test that with paper. It makes sense in terms of distances. I may have put it straight down here somewhere. Actually, I prefer to have gone down here to see how it goes. But you can try this out at home. So according to the answer book, I've certainly got a 90-degree anti-clockwise rotation, but I'm disputing the centre until I actually see it work. So it says it's -1/2, 3, but try it out yourselves. Essentially, with tracing paper, you know, that won't lie to you. You don't have to play on the screen, and I'm not going to play any further with that one. So I'm going to stop there. So we've got 3 congruent images of P. We've got Q, a reflection. We have S, a translation, and R, a rotation. I'm just disputing the centre. Can't really tell working like this, so I'll leave it as it is, and we'll see how we go later on. So you try it out and let me know what you think.